Hey, welcome everyone to this month's training class. We're happy you guys could make it. What are we going to be talking about today, Fritz?
Well, we're going to be talking about graphing using our computer or
Our scanner, okay, scan tool graphing, awesome.
Exactly. I know that most of you have an expensive scanner. You just use it to check codes or pull out codes.
Sure.
You'll be surprised how much more that baby can do.
All right, great.
And we're going to run through a set of codes, and we're going to talk about conditions for setting the codes and what the PCM looks for.
Okay, so like code set criteria.
Exactly.
Okay, great. And what else?
And
our diagnostic process, right?
Exactly.
We're going to add some more steps to that, add some more tips into the diagnostic process, because that's super important for diagnosing quickly, efficiently, and accurately.
Right.
Because time is money.
It's true. The information we'll give you guys today is going to illuminate a lot more than just pulling the code and thinking that the code is going to give you the solution to the problem. We're actually going to take you step by step, show you how to graph and what to look for and the conditions of the codes you're actually pulling out of the PCM.
Right, so like a map sensor code isn't for replacing a map sensor, it's for diagnosing map sensors. Saying the computer's testing it and it failed doesn't necessarily mean replace the map sensor.
Right, you can have an intake vacuum leak.
Could be.
Exactly.
So we're going to talk about that kind of stuff. But first, we got to give away our t-shirt. So show them what they can win.
Here's our t-shirt contest. And Mike is going to read the question, and whoever answers it, you know what to do.
All right, here we go. So up on the screen here, you see Technician A says, graphing data on a scan tool replaces the need for a lab scope. Technician B says, the more data or graphs on the screen, the slower the scan tool will refresh. Okay, who's correct? Tech A, Tech B, both techs, or neither? So go ahead and submit your answer in the chat box. It's going to be either below the screen, below the video, or off to the right side of the video with either A, B, C, or D. And they'll be entered in to win the t-shirt. So whoever answers correctly will win a shirt. So good luck with that, and good to go. All right. Let's talk codes. Let's talk trouble codes. Let's start with a P0101. So bring that up on the screen here. You can see in the upper left corner it's for a 2003 Grand Prix. We pulled this right off of AllData because the vehicle in our shop today is an 03 Grand Prix. Right. So that's what we're going to be doing our graphing on.
There's one thing I want to say before we keep going.
Okay.
For most of you out there, it may be just a refresher or, touch back on what you know. But this class that we're doing is for the people who are coming behind you that don't really know how to use their scanner.
The up-and-comers.
Are learning. This is why we're doing this step by step, and we're taking it very slow.
Sure. And for you guys, the master techs out there and everything, this might be a good review. It might be a good remembering of something that you had learned a long time ago.
That's right.
Or it might already be part of your diagnostic process that you do. That's great. Then this might just be review, but stay tuned.
Okay, so
what's a 101?
Well, it's P01, we got a mass airflow sensor concern.
Okay, and we can see that under circuit description. If you didn't know what a P0101 is, say you're new to fixing cars, you can find that information under circuit description when you look up the code. So it says there that it's a mass airflow sensor is used to measure airflow going into the engine. Okay, that's great. It's got 3 wires, ignition 1 voltage circuit, ground circuit, and signal circuit. Okay, great. The second line talks about applying voltage to the sensor signal circuit to create a frequency based on the inlet airflow. All right, so that's how it does it. The frequency varies between 2,000 to 10,000 hertz at max load, and the PCM uses the following sensors inputs to calculate a predicted mass airflow. So what are those sensors?
Well, we got the barometric pressure.
Okay.
Manifold absolute pressure, which is your map.
Right.
Intake air temperature, engine coolant temperature, throttle position, your throttle, and your engine speed.
Okay, so it's taking all these to predict a mass airflow value, but why is it predicting mass airflow?
Well, the reason why is because the PCM has already got its parameters built into it.
Right.
It knows what it wants to see.
Okay.
So as she runs the test, constantly is running tests, she wants to see all these sensors fall within her parameters. Okay. Once one of them starts to fall off, she checks it once, twice, sets a code without illuminating the light.
Right.
Until she sees it again couple more times, and then
Okay.
she'll actually illuminate.
And that information's in here. It says
Exactly.
here, the PCM compares the actual mass airflow sensor frequency signal to the predicted mass airflow value. So it's taking the actual, comparing it to the predicted. And you can see under conditions for setting the DTC, the PCM detects that the actual frequency is not within the predetermined range of calculated for more than 10 seconds. So it's a little bit wordy, but what they're saying is the predicted value here, the computer has predicted that value from all those sensors. It says this is the frequency reading we should be seeing. This is what these sensors are actually reporting to the computer. It's going to compare the two against each other.
Right.
It's got to be within that range for more than 10 seconds. If it's not in that range, it's going to go ahead and set a DTC. But you had talked about before that it's not going to set the check engine light right away. And how do we know that?
Well, because it'll see it more than one time. It'll actually see it after a second cycle.
Okay, and we know that from looking at the action taken,
Exactly.
right?
Exactly.
So that action taken says that the control module will illuminate the mill light on the second consecutive ignition cycle that the diagnostic runs and fails. So it runs the test, fails. It has to do it again on the next ignition cycle, and then it'll set the light. It could set a pending code though,
That's correct.
but it will not set the light until it fails 2 times, and that's known as a 2-trip code.
Exactly.
So that's good to know. If you're trying to duplicate a problem, it has to fail 2 separate ignition cycles, and you can find that information under action taken. Also under there, it talks about the control module recording the operating conditions, freeze frame data. So it's going to record freeze frame data when the DTC sets. But when does it test, or what does it need to have in order to test those conditions?
Well, then there's where you go to conditions for running the DTC.
Okay.
You know, first of all, the engine's, of course, the engine's got to be running.
Right.
The ignition signal's got to be between 9 and 18 volts.
Well, it can't have any of these codes set either, right?
Well, that's true. None of these codes can be set, because if it does, it won't run it.
Okay, so if any of these other codes are set, if you have any of these other P codes in there, it's not going to run the P0101 test.
Right.
Okay, what else?
So, well, then you got your TP angle. It's got to be less than 25%. So practically it's looking at idle or a constant.
Right, so like a cruising down the road, maybe cruising down the highway, you're only at maybe 12% TP, something like that.
Exactly.
Nice and steady.
Then, of course, it does not want to see a TP change no more than 1.5%.
Okay, so it's really looking for steady on that TP.
very steady.
Okay.
The mass airflow has got to be
No,
less.
map sensor.
Oh, sorry. The map sensor has got to be less than 63 kPa.
Okay.
And the change on the map sensor has got to be less than 3 kPa.
Okay, well that makes sense. So it's talking that it wants a nice steady running engine to determine this mass airflow sensor test.
Right.
Okay. And it's got to meet all those conditions for more than 5 seconds.
Exactly.
So it's going to meet these conditions. So it's going to take all these, it's essentially the computer's got a checklist. So it meets all these conditions, checks them all off, says, okay, all these conditions are met, I'm good to run the test. So it's going to run that test for 10 seconds then, and either pass or fail. If it fails, sets the DTC as maybe a pending code, but it doesn't immediately illuminate the check engine light.
Right.
It has to fail twice. So let's go on to the next code. We got a P0107. What's that?
That's a map sensor.
Okay, manifold absolute pressure.
Exactly.
Okay, so you can look under circuit description again. It says that it has a 5-volt reference, low reference, which is ground, and a signal circuit, and that the computer supplies the 5-volt reference, ground, and signal. So all that information is transmitted to and from the computer, the voltage, the ground, and the signal.
Right.
All right, so those conditions, again, are similar to our mass airflow, right?
That's right. If you can see the conditions, you read them. Engine's running greater or equal to 400 RPM, actually.
So, okay, so it's
Idle.
got to be at least idle.
Right.
But it can't have any of these codes set again. So you got to look through this code list again, make sure that those aren't set in the computer.
That's right, because if it has codes, it will not run the test.
Any of these codes, right?
Or any of these codes, it will not run the test.
Okay.
Then the throttle's got to be equal to 0% when the engine is less or equal to 1,000 RPM.
Okay.
Or the throttle position sensor's got to be greater than 12.5% when the engine speed is greater than 1,000 RPM.
Okay, so it's kind of a little bit of a rationality check on the TP. So basically they're saying the throttle position sensor has to be functioning in order for the map sensor to run the test.
Right.
Okay. And it says there too that the DTC continuously runs when the above conditions are met. So this is a constant monitored DTC. So the 107, as long as these conditions above are met, it will run the test continuously.
Right.
All right. So the setting of the DTC, what the computer is actually testing, it's looking that the ECM or the PCM, the computer, detects that the map sensor's voltage is less than 0.05 volts for longer than 5 seconds. So you have a map sensor not responding, it's at 0 volts or 0.01 or something like that. If it's doing that for longer than 5 seconds,
Exactly.
sets a DTC. All right. On to the P0121. What is this one related to?
Well, this one is throttle position sensor.
Okay. And it says that the throttle position is used to determine throttle plate for various engine management systems, and that it's a potentiometer type sensor with 3 circuits. That's all good information to know. It's got a 5 volt reference again, low reference, which is ground, and signal. All right, so the TP is going to take a 5 volt reference circuit, and it says here the PCM will use the map sensor to determine if the predicted operating range of the TP is correct. So again, the computer's predicting a range from other values. So we can find that under the conditions again, right?
Right.
All right, so what are those conditions for this one?
Well, the conditions are the engine has got to be running for at least 2 minutes.
Okay.
The coolant temperature has got to be at least 75 degrees or higher.
75 Celsius.
Celsius.
That's 167 Fahrenheit, which is a warm engine.
Right.
It's got to be warmed up.
Right. The map has got to be reading 50 kpg.
KPA.
Sorry. And the TP squid is a height test.
Okay, for a skewed high test, it's
Skewed
got to be
height,
less
yeah.
than 50 kPa.
Right.
Okay.
And the map reading is more than 70 kPa for a TP
Skewed
for a low test.
Okay.
Okay.
And the map sensor has to be steady for 5 seconds or more. So it's looking for a steady test again. And that could be cruising down the highway again or at idle. Okay, so that's good information to know. But the most important thing on this is those DTCs again. So you see the DTC 107, we just talked about that, a map
Right.
sensor code. So if this vehicle driving down the road has a map sensor code in it, it's not going to run a TP test.
That's correct. So that's one of the things that most of you probably didn't know. If you have a code, and I don't think we mentioned this, when you get a vehicle in the shop, and for example, a customer has already been tinkering with it, unplugging things.
Sure, you got a whole bunch of codes.
Exactly. So the car comes in, you run your codes. Make sure you run all the codes, all the modules. You write them down. You
Document them.
Document
Gotta document.
erase all the codes, take the car for a test drive.
Okay.
If you have to drive it more than one time, do so. And bring it back to the shop, run the codes again. Even though you may not have a light on there, you
Sure.
may have a codes already,
Like a pending
a
code.
pending code. And then start with the lowest code,
The lowest number. So
lowest number, right.
Okay, so you would start, out of our code so far, you'd start with the P0101.
Right.
But that's really interesting in the fact that the conditions for running this 121 code, you can't have that 107 set. It makes sense. It needs to see the map sensor functioning normal in order to test the TP.
That's
Okay,
right.
that's great. So what if you say, we've all run into this. A little example. Customer comes in, check engine light for whatever, P0107. You fix it, you replace the map sensor, whatever it ends up needing. Vehicle goes out, it's running great, everything's fine. Customer comes back a few days later, maybe a week later, check engine light's on again.
Right.
I mean, we've all seen that, right?
Oh, yeah.
Well, it could be because there was another code in there, another test that wasn't able to be run because it was set in that 107 code. So it could be that the TP sensor here wasn't functioning normal. The 107 was set so it wouldn't run the 121 code test, okay?
That's right.
So it's really important information to note and kind of good ammunition to go back to your customer with and say, I'm sorry, customer, but this is a different problem. It never ran this other test because the first code that you had, the first problem,
Exactly.
didn't allow it to run. So that's really good to know. I mean, that can really save you from it from being a comeback complaint to another problem.
Right, and by knowing this now, by knowing this, you can always tell the customers, hey, by the way, we fixed this code. Doesn't mean that it could be another problem with the vehicle. Drive it. If it's okay for 2-3 weeks, then we're good to go. If the light comes back on, bring it. I'll check the code. Then you already got the code that you worked on first.
Yep, documented.
Documented, and you can say, hey, we had a PO 171.
107.
107, and now we get a PO 121. They're
It's
not
possible.
the same thing. Exactly.
It's definitely possible. And then you can explain that, I'm sorry, but the computer didn't run the test for this other code because it had that previous code already in there. So that's really, really good information to know, and really good for when you're trying to duplicate problems and that kind of thing, because you have to know what the conditions are for running the test. So for our map sensor, or excuse me, our TP sensor problem, it has to measure the TP voltage more than its predicted value, and this is for setting, more than predicted value when the map sensor is less than 50 kPa or less than the predicted value when it's over 70 kPa, and it has to do this for 5 seconds long in order to set the light on. So that's really good information to know. Let's go on to another 121. Now this is on a newer car. This is on a 2008 Impala. This 121, again, still going to be a TP sensor. So let's just talk 1 second here. Just step back and look at trouble codes as a whole. Trouble codes from P0001 all the way to P1000, they all are going to be the exact same thing. They're mandated by the government. So 121 is always going to be throttle position related. 107 is going to always be map sensor related. A 171 is always going to be a lean code. All manufacturers selling vehicles in the United States have to have that mandated trouble codes. Okay, so they're always going to be the same. That's why working in the business for a long time, a lot of technicians are able to memorize those codes because they're so often to come up. OBD1 guys, that was easier when they only had a few codes.
That's right.
Now we're moving into the thousands of codes on newer cars, and then they get into manufacturer specific. So anything over a P1000 is considered manufacturer specific. You can get into the 2000s, I mean, it gets crazy on new vehicles. You get acronyms, you get A or B or C depending on circuit fault. It gets crazy, but this information on these pieces of paper right here can save you a ton of time in diagnosing.
That's right.
So let's get back to this 121. So we'll back into this.
Okay.
Got sidetracked. All right, so again, it's using all these sensors to calculate that airflow rate to get a predetermined value. That's all good to go. What I want to take out of this 121 on this newer car is that action taken when the DTC sets. So it talks about it being a type B DTC, that's great. But what we want to know is this ECM commands the TAC system, which is throttle actuated control, drive-by-wire. It commands the TAC system to operate in reduced power mode. That is really important to know. So you have a vehicle coming in, customer complaint, vehicle goes into reduced power mode. You have, say you have a bunch of codes in there. You pull this 121, you can see that that is what's causing the reduced engine power mode. That's how you can know what exactly the computer is going to do or command when it sets a specific check engine light, or a specific DTC. Is it commands certain things to do certain things. Set a light, put in reduce engine mode, maybe it'll run it a certain way, who knows. It'll predetermine all that information inside the computer, and these lists of information are going to include that type of stuff. So that's all really, really good stuff to know. I think that's about all we want to talk about on codes, right?
Yes. Now we should go to the car and show them how to graph.
All right, let's go to the car. We got the Veris hooked up to our 2003 Grand Prix, and we're going to do some graphing of TP, map sensor, mass airflow, and a few other things. So let's do it. Check it out. Let's go.
Let's go.
All righty.
Okay, here we are.
So here's our Grand Prix. This is 03 Grand Prix with the 3.1 liter. So why do we graph with a scan tool, Fritz?
Well, we use graphs to watch data in time as the vehicle's running. We can see what the component's doing over time, right?
Okay, so it's kind of like the difference between PIDs, watching the PIDs or the live data, versus watching the graph is kind of like looking at a multimeter where you get the number just for that second, or watching it on a lab scope where you get that number over that spread amount of time.
Exactly.
So I guess that's the main difference, and there's some sensors that we really want to watch that on.
Definitely.
So I guess let's show a couple of those. Let's show some graphing.
All right, let's do it.
All right, so I'm going to get this all set up here. All right, so what we're in right now is this is just the engine data list view, just like we had showed last class. As soon as it loads, there we go. All right. So on the screen here, you can see all the data that we were looking at last time. Very similar. Different vehicle, obviously, but very similar data. And the first thing that we're going to show is let's show the throttle position sensor. This is a common thing to graph because you want to do what's called a sweep test. You want to slowly push a throttle down and release it, looking for that nice scaling up and scaling back down, watching for any sort of dropouts or anything. And a dropout would signal what?
A flaw in the TP or,
Right.
or a glitch in it.
Sure. So a glitch in it could be, it could be a wire.
Yep.
But it's at least showing that there's something in there that's glitching. So you would use graphing for that. So what I'm going to do is I'm going to go onto the scan tool here, and we're just in our live data. And I'm going to click these little arrows right here. And this is going to bring up a graph right in the scan tool. So you can see, there we go, there's our voltage. And I'm going to go ahead and click our percentage too. And so there we go. Why don't you go ahead and just push the throttle pedal down, and let's see what it looks like. And I'm not seeing anything. We're getting an NA here, so maybe the scan tool ran into an error. Let's back out and try this again. Go back into engine data. Sometimes we run into errors with the scan tool.
Yep.
I'm sure you guys have all run into that in the shop as well. Apparently, we have some old information here. Let's look. Okay. So let's get back to our list. And see what we got this time as it loads. There we go. Okay, we got our voltage reading. We're at 0.63 right now. There we go. Now we're getting numbers on the side instead of just NA. And we'll bring up our percentage. So why don't you go ahead and hit that again, Fritz. All right, so he went really fast with that. You saw it go 0 to 99. Try it again. Sometimes, like right there, we heard it go again, but there's not 2 on here. The scan tool's not fast enough. It wasn't quick enough to pick that up. So the scan tool is only able to read so fast, and if you're doing some sort of fast test like that, it's not going to pick it up all the time. And now there's a couple things you can do to help speed it up, but it's never going to be like a lab scope, you know.
That's correct. It's not fast enough.
You hook a scope to it, and it's going to be instant. You're going to see exactly as fast as you can do it. It's cycling and watching multiple times more per second. Scan tool's only able to get so many times per second to sample. So we can speed this up a little bit by changing a few things. First of all, we can go into custom view, and this is going to bring up custom data. And all these blacked out pieces right here, these are all the selected things right now. So what I'm going to do is deselect all of them. And I'm going to bring up TPS percentage and voltage. So now I'm just going to show these two. Go back to our list view. And you can see now we just have 2 PIDs on the screen, and it loaded a lot faster this time because the scan tool's not having to work as hard to produce all that information. It's only producing a few little things. So go ahead and do that pedal down again. And there we went nice and fast. Do it again. So here you can see it's capturing every time again. So right there, looks like you didn't get that pedal pushed all the way to the floor that time maybe. Try again. There we go. All right, so you can see now the scan tool is reacting faster and showing us all of those increases and decreases. Why don't we do like we would do a sweep test, nice and slow scaling. So as you can see, he's slowly pushing down the pedal, and it's increasing. And what we're looking at doing a sweep test is we're looking for this voltage to drop somewhere or to increase somewhere, some sort of glitch in the voltage reading or the percentage reading, either side. Just looking for some sort of change that's not supposed to be there. And go ahead and bring it back down. And everything looks really nice. There's no sort of weird glitches anywhere in there. We know that this TP on this car is good to go. So you'll run into this when you get a TP code, some sort of drivability issue.
Right. Sometimes you may have a bad connection with the connector.
Sure.
And it'll act up. If you do a sweep and it's working just fine, you do it several times like we did, take a look at your connector. May have a problem there.
Could be, and you might want to do a sweep test with somebody wiggling around on wires and test, and while you're sweeping the pedal, anything like that. And you get into newer vehicles, they're going to have more than one TP, so you'll compare them against each other. They should cross at some point, that kind of thing. So that's one test we can do. Let's do another one. Let's throw the map sensor on here too. We were talking about map sensor. So let's throw that in here. We'll throw in inches of vacuum and map sensor voltage. And instead of going to list view this time, I'm going to go to graph view. And what this will do is just bring up our 4 graphs. So we have map vacuum, map voltage, TPS voltage, and TPS percent. So right now we're at atmospheric vacuum. We're at atmospheric pressure because there's no vacuum being created by the engine. If Fritz goes ahead and cranks this engine over, the engine's going to start to make vacuum. If it starts up and runs, it'll create idle vacuum. If we're just cranking, though, it should create some amount of vacuum. And that right there is going to tell us that we have compression in the motor.
That's correct.
But it's not really a compression test, I wouldn't call it. But at least you're able to verify that the engine is capable of creating compression, capable of creating vacuum in the intake, and the map sensor is able to read it. What is another time? So you could have like timing belt issues, timing chain. You had brought up one with where the cylinders.
Yeah, if the cylinders are washed,
Sure.
you will not see that.
Right. So you're not building compression in washed cylinders, so it could cause that. So and you can prove that out by doing a test like this. Go ahead and crank it over, Fritz. So you can see as he's cranking. All right, let off. Our map sensor dropped down here. Our voltage dropped, meaning that we're creating vacuum in the engine. Go ahead and do it again. So we're dropping down to like that 4.3, 4.4 volts mark. Okay, let up. What we want to see is about a 0.3 of a volt drop in our vacuum reading on our voltage for our sensor. So you want to see 0.3, and that at least tells you that the engine's capable of creating vacuum, so it must have compression and it's able to breathe at least. It's not as good as doing a compression test or a relative or running compression test, but it's a quick, easy test, right? I mean, this took us 2 minutes to do. You hook the scan tool up. At least now we just verified that our map sensor is functioning and our engine has some sort of compression. So let's do this one step further. Go ahead and crank it over again. You'll see our map sensor drop down. Now this should return back to atmospheric when Fritz opens up the throttle. Go ahead, open the throttle. You saw throttle voltage jump up and map sensor return to atmospheric. Okay, go ahead, let off. So that's a good test to show that our TP is responding. Oh, did you shut the key off?
Nope.
Oh, we lost the scan tool. Let's get back into there. And we'll go to graph view. Oops. Open up all 4 again. And select graph view. Okay, try it again. All right, you can let off. So again, when he opens up the throttle, you can see that the vacuum inside the manifold goes back to atmospheric because the throttle plate is open, then there's no restriction.
That's right.
And that shows us that our throttle position sensor is functioning, our throttle is actually opening. So that's a good test to justify or verify that the throttle is actually opening.
That's right. If we had a stretched out timing chain or valves were dirty or anything that would cause that to change, we probably wouldn't even see that difference right now.
You might not, yeah. Or it might only drop, say, a 1/10 of a volt or something. Right. Or say we have washed out cylinders or you know, something like that. At least this way you're able to show it. So okay, let's go ahead and throw this fuse back in and fire this thing up and see how our map sensor responds. And so now we should see our vacuum is going to drop even more because idle vacuum, the engine's moving faster, it's going to drop even more. Go ahead, fire it up. All right, there we go. So you can see our vacuum reading is it's pretty steady at about 1.5 or so volts. And right now our TP is closed, our throttle is closed. So now if Fritz goes ahead and he gooses the throttle right now and hits it hard, we should see this vacuum spike back up to atmospheric because he just opened the throttle plate and allowed a ton of air to rush inside the motor. This vacuum is not able to overcome that at that point, so it's going to spike up. But now if you close that throttle plate and close it back to sealed up while the motor's spinning fast, it's actually going to draw more vacuum than it would at idle. So we're going to see it go up and we're going to see it drop down and actually dip lower than our idle line. Go ahead and do that and let's show that. So there we go. I'm going to actually pause this All right, you can shut it off. Just leave the key on. All right, so you can see right here, it increases back to roughly atmospheric pressure and then drops down below the idle vacuum because the way the throttle and the air rushing into the engine, that mass amount of air going into the motor is affecting the map sensor. And our TP is responding exactly like it should be. He hit the throttle, opened the thing all the way up, throttle plate went full open, and all that air rushed in. And this is good to be able to see that.
Yep.
I mean, that's showing that our map sensor is responding normal. All right, so that's map sensor and TP. What is going to be probably the most common one, Fritz? What's something you graph the most at the shop?
O2 sensors.
O2 sensors? I would agree. That's probably what I would graph the most as well. Because we have to be able to watch O2 sensors over time. We have to watch them switching, right?
That's correct.
All right, so let's see what we got here. Let's go back to our custom data and see what we got for O2s. I'm going to deselect all those. Looks like we got 2 O2s on this car, which makes sense because this has one post pre-cat and one post-cat. So I'm going to go ahead, I'm going to do graph view again. Bring up these O2 sensors, and we're reading NA. So maybe the scan tool's not responding. Why don't you go ahead and fire it up and see if we get some response. I'm going to bring it up into list view. All right, exit out. Go back in. All right, we'll go back into our custom data and change it again. Graph view. Okay, there we go. So now what we should see from our oxygen sensors, and I'm not going to get very deep into O2 sensors this class because we're going to have an entire class on O2s and fuel trims and all that stuff. Today we're just going to be talking kind of a brief, just looking at the O2 sensors. So as we look at the graph here, you can see our switching back and forth. This looks like a good pre-cat O2. We should see it switching from lean to rich,
That's
like
correct.
normal.
Yep.
And there's a set amount of time it has to switch per second. And we're not going to get into that today, but we'll get into that in the next few class in the next few months. We're going to be doing just O2 sensors and fuel trims. But now let's take a look at our post-cat oxygen sensor. So you can see that's switching also. Is it supposed to be?
Not that much.
It's going to be the bonus question of the day. So bonus question. If you answer this one right, you guys can get a t-shirt. If you already answered the first question though, I'm only going to send you guys one. But for those of you who didn't answer the first one, here's your chance at a second chance to win. So is this oxygen sensor here, this bank 2 sensor right here, is this normal, this sensor tube post-cat, is this normal for a post-cat oxygen sensor to read? Is that a normal reading? So go ahead and comment in your answer for that and see what you guys say. So, all right, I think that's about it for graphing then, right?
Okay.
You can go ahead and shut it off. So those are just a few examples of something that you might want to graph on the car. And really graphing is just watching the data over time, just like a lab scope versus a multimeter. It's going to be the same deal. So, yeah, I think that's probably about it for that,
Yep.
right? All right, let's see if we have answers for the question. Remember the question today was, Tech A is saying that graphing data on a scan tool replaces the need for a lab scope. I think we've answered that already.
Yes, we did.
Tech B says the more data on the screen slows down the scan tool's refresh rate.
That's true.
I think we answered that one too. So the correct answer would be Tech B. And it looks like we got some correct answers here out of Doug B said B, Henry Schrader, and Raimundo Vasquez. They all said B, so awesome guys, nice job. If we can bring up the email address on the screen here, you'll see there's my emails. Shoot me out an email with your mailing address and t-shirt size in there, and I'll make sure to get one sent out to you right away. And Doug B commented and he said not normal, needs to warm up. Well, let's show Doug once what we got going on here. You want to fire this thing back up for me?
Sure.
Let's get back into our data. All right, here we go. All right, So why don't I add to our custom data here? I'm going to throw one more in here for you, Doug. All right, let's find, here we go, coolant temp. We'll throw that in there. That'll signal if it's a warm or cold engine. And of course it's reading NA. I don't know why it keeps doing this. There we go. All right, so there's all of our graphs. These two got switched around here. So this is our pre-cat, post-cat. And you can see the engine's at about 163, 165. So the engine's warmed up. This is normal for the pre-cat sensor. It should be switching. The post-cat sensor should not be switching like this. It should actually be relatively steady, a pretty much flat line. It's going to change a little bit, right, Fritz?
Yeah, most of the times you'll see it change a lot when you goose the engine.
Okay, sure. So we might see some fluctuation out of that line, but it should be relatively steady, relatively straight. And what that's actually showing is that the cat is doing its job.
That's right.
This is actually signaling that the cat is not functioning right, but the sensor is warmed up and ready to work. If it wasn't warmed up, we would actually most likely see a flat line right around bias voltage of about 450. But we're going to get into that in our oxygen sensor class. You can go ahead and shut it off. We're going to get into that more, talking about bias voltage, switching, all that stuff, once we get into our oxygen sensor and filtering class.
That's right.
So I think that's about it for today, right? We talked about graphing. We brought up some trouble code stuff, some good points to add into your diagnostic process.
Right.
Is there anything else you wanted to talk about?
That was about it.
Okay. Our next class is going to be November 10th. It's a week later than normal because we're going to be at SEMA and Apex in Vegas. So check out our Facebook page during that week, the first week in November. Hopefully we'll have some videos out there from SEMA and Apex and maybe even some giveaways that you guys can have a chance to win some t-shirts. And November 10th will be the next one. And I think we're going to go over mode diagnostics like mode 6, mode 9, mode 1, all those kind of engineering side of things.
Right.
That's useful stuff, right?
Exactly, especially on foreign cars.
Yeah, or Ford trucks.
Ford trucks.
That's a good one too.
Mode 6 is my favorite.
Yep. So I guess that's about it for today.
Yep, that's about it.
So if you guys want a t-shirt, send me out an email, and I guess we'll see you guys next time. Without you being there, we would not be here, and we'll see you next time in the Wells Tech Garage. Thank you.
Yep. Have a good one.